Hi, my name is Jayaprakash. In this video, we're going to discuss about bit manipulation and as well as Endianness. So what is bit manipulation? Inside the system, we know that all the data will be stored in binary form. For example, if we take the value of 5, the value of 5 will be stored as 0101. So each 0 and 1 is a bit. What is meant by 0 and 1? That it might be false, it might be true, and 0 will be off and 1 will be on. So we'll directly work on these bits. That is nothing but a bit manipulation. Why we use bit manipulation? We use a bit manipulation when we want to modify only a specific part of the bit without affecting other bits. Suppose if I have value 5, if I want to make it 6, I'll just change the bits and make it to 6. Or else, how can I change? I'll just assign the value like 6. If I assign the value, it will replace the entire bits. That means after assigning 6, we don't know which bit is changed and what happens there, and the entire number is replaced. So this will make us to lose the precision control over it and efficiency, because unnecessarily we're modifying the many bits, we don't know which bit is modified. So by using this bit manipulation, we'll have the control over the bits or the number. There is no scope of modifying other bits, we can only change the targeted bits what we want. So without bit manipulation, if we assign the value, suppose if I have x equal to 5, so when I change it to 6, we don't know which bits are changed, but it will give the value, whatever the value we desire, it will give. But we don't know which bits are changed, and we don't have control over the bits, and so that is the problem with our bit manipulation. So by using this bit manipulation, we will have the control over which bit we have to change. So to perform these bitwise operations, we will have some operators like bitwise operators, such as AND, OR, XOR, left shift, right shift, and these are the operators used to manipulate the bits. And let us discuss about AND, OR, and XOR and what are they going to do here. So with the help of these operators, we can set, clear, or toggle a bit. So what is meant by set? Set means nothing but just making a bit as 1. So what do you mean by 1? It is just turning on. So let us see here the OR operation. So OR with 1 always produces 1. Whatever the bits you take, whether it is 0 or 1. So whenever if we do, or if we want to set a bit, just make it OR with 1. So it will give the output as 1. I will see the example here. Suppose if I have n value equal to 5, the binary will be 0 1 0 1. So I want to make it as set. So I want to make the 0 as set. So what I'll do, I'll just take masking. So here I'll have 1. What is the position of 0 here? 1 0 1 2 3. So what I'll do, I'll make position as 3. So now I'll shift it 3 times. At first the 1 will be here. What is the value of 1? 1 equal to 0 0 0 1. This 1 will be shifted to here 3 times. 1 2 3. So here we'll have 1 0 0 1 0. To get output here, or to make it a set bit, I'll just take OR operator. 1 with 0 1 0 with 0 0, 1 OR with 0 1, and 0 OR with 1. See, what happened is we didn't change remaining bits, we just changed the last bit only. The bit which we want to change, it is only changed to 1. The remaining bits are unaffected. This is how the OR operation works. And this is the basic syntax, the number which we have to perform bitwise operations, and it is the mask value. Here we are using left shift. So this is about OR operation, and a bit is set using OR operation. Next, clearing. So what is meant by clearing? Clearing is nothing but making a bit as 0. So here the AND operation is performed as shown here. 0 AND with 0 will give 0, and 0 AND with 1 will give 0. And what does this indicate means? So if any value is low or any value will be 0, if you perform AND operation, it will be 0, the output will be 0. If you want to get the output as 1, both the values will be on. So now let's see the same example here. If I want to clear this bit, what I'll do, what is the position of this bit? This is 1 2. Here the position is 2. I just want to make it clear, I just want to make it 0. So what I'll do, the position will be 2 here. It will shift 2 times, and this value becomes 0 0. It will be 0, this will be 0, this will be 1, and this will be 0. What happened, bro? What happened here? I just want to make it a clear bit, but what happened is it became a set bit, but this bit gone as clear bit. So this will change the value. So what we have to do now, we just made a mistake here. So in order to perform AND operator or clear a bit, we need to perform NOT operator here. Perform NOT operator means inverting the bits. We'll just invert it. After this shifting, we'll use inversion. This is the syntax for clearing a bit. Shift the bits and we have to perform nothing but inverting the bits. 1, 0, 1, 1. Simply I'll just make changes here. 1, 1, 0. Now let's perform the operation. 0 and with 1 it will be 0. 1 and with 0, 0. 0 and with 1, 0. 1 and with 1, 1. So now what happened? So whatever the bit we are looking to change as a clear bit is cleared now. And the one bit which is already available there is not affected. So this is how AND operation works. So this is the basic syntax of AND operator work. We have to perform the AND operation, shift the bit with the position, and we have to invert it with the NOT operator and just perform AND operation. Next, toggling a bit. Toggling is nothing but switching or flipping the state of the bit. If it is 0, it will be 1. So if the bit is 0, by toggling it will become 1, and if it is 1, it will become 0. So here is a truth table for it. 0 XOR with 0, it will be 0. 0 XOR with 1, it will be 1. What does it defines means both inputs should be different states. They should not be the same state. So now we came to know how the bitwise manipulation will work. Now let's see the applications of bitwise operators, where we see the bitwise operators and what are they working. So for example, we see here in hardwares like registers, Arduino and any microcontroller, we'll have the pins. The pins will be assigned with zeros and ones. Each pin on a chip is controlled by a single bit. What is the operation we do on chip? Either we'll enable it or we'll disable it. So for enabling, it will be in on state, like it is 1. Disabling, it will be 0, it will be in off state. This is how the bitwise will work on pins, like performing the operations of disable and enable. Suppose if we take our mobile phone, we will have the options like Wi-Fi, Bluetooth or any other flight mode. What happens here is simply when you press the Wi-Fi on, simply you are just seeing the Wi-Fi will on and off. But internally, Wi-Fi will have a hardware. So whenever you press Wi-Fi button, internally the bits will be changed from 0 to 1 or 1 to 0. If the Wi-Fi is on, the bit will be changed to 1. If the Wi-Fi is off, the bit is changed to 0. This is how it works internally. And also if you take the real-time example as LED control. Suppose if you want to switch on a light, what you will do, you will just press the switch. It will trigger, and if it is 1, the LED will on. If it is 0, the LED will be off. The LED is controlled by a single bit, which is switched on or switched off. In embedded systems, we have direct hardware control. So we'll have the registers like port A is directly connected to the physical pins. And in that registers, we'll have the pins like port A, port B, which will be worked as the switches. So initially the value of port will be 0. And whenever we press the switch will trigger and it will be turned on. Because we are using R operator, the bit will be set and the pin will be turned on. And again, whenever you press again the second time, the switch will be triggered again and it will become 0, means which indicates the LED is turned off. So like this, the switching operation will go on. So by these bit manipulations, we can conclude that these bitwise operators are the main in using switches or making one thing turning and turning off or enabling or disabling in our mobiles. It is not just a technique, but it is the foundation of how software talks to hardware. Let's dive into Endianness. So what is meant by Endianness? Endianness is the order in which bytes are stored in memory. When we store a multi-byte value, like an integer, it is divided into bytes. Endianness will define the order in which those bytes are arranged at consecutive memory addresses. Now what is meant by order? This Endianness is of two types, little endian and big endian. In little endian, the least significant bit is stored at the lowest memory address. And in the big endian, the most significant bit is stored at the lowest memory address. So let us see an example of little endian and big endian. So this is the example 1, 2, 3, 4, 5, 6, 7, 8. And this is a 32-bit hex value and it is consists of 4 bytes 1, 2, 3, 4, 5, 6, 7, 8. So this is how it is stored in the little endian and as well as in big endian. So we know that in little endian LSB is stored at lowest address. This is the LSB, it is stored at lowest address. Lowest address will be 0, 0. And this is how it is going to store 78, 56, 34, 12. And when it comes to big endian, the MSB. What is MSB? This MSB will be stored at the lowest address. So what is the lowest address here? This is the lowest address. This MSB will be stored here. So this is how it works. The lowest address will have the MSB bit. So this is how the Endianness will work. Up to this it is okay. We came to know that what is Endianness and what is Little Endian and Big Endian. So let us know why this Endianness is important, where this is going to be used. So whenever we are going to transfer the data between two devices, suppose if we take this system as Big Endian and this will be as Little Endian, when we are transferring the data between those two devices, the memory should be matched, or the order of which the bytes are stored should be matched in both devices, so that transfer will be done efficiently. Suppose if I am sending a data from Big Endian to Little Endian, what happens if the system is Little Endian? It must rearrange the bytes correctly. This Endianness is used in network communications like protocols, TCP, IP. In network communication, data is usually sent in Big Endian format. So it should rearrange its bytes according to the other device. When binary data is written to a file on one system and read on another system, the byte order must match. Okay, the order of the bytes which the one device is stored, so they should be matched. Whenever the byte order is mismatched between two devices, so before transmission, we convert this data into a standard byte order, and after receiving, we'll just convert it back. Till now we have completed what is Endianness and what are the types of Endianness and what are the applications of Endianness. Now, what type of Endianness does your system has? So in order to check this, we'll just use this program. So now in order to detect the Endianness, we'll just use a variable here as one. I am not going to take any bigger values, I'm just going to take a simple value. And this is how it looks like. The pointer, now it is the pointer pointing to the X. So if the pointer points to 1, then it will be Little Endian, and if the pointer points to 0, then it will be a Big Endian. If it is a Big Endian, the value will be stored as 010000 like this. This is how it stores in a Big Endian, and this is how it's stored in a Little Endian. By using this program, you will be able to know which system you are, Little Endian or Big Endian.